proportions, we're going to talk about two specific ones today. We're going to talk about relationships that are directly proportional and then relationships that are inversely proportional. So, a direct proportion is as one quantity increases, the other quantity increases proportionally. These quantities are said to be directly proportional. So in the blue box here, it shows that as one value increases, the other increases proportionally. And if one value decreases, then the other also decreases proportionally. So we're going to do a couple examples with this. The first one is electrical resistance. So the electrical resistance of a wire is directly proportional to its length. That means the longer the wire, the greater the resistance. If 1 foot of nichrome heater element wire has a resistance of 1.65 ohms, and the length of what length of the wire is needed to provide a resistance of 19.8 ohms. So we're looking for L in the second picture of the wire here. So to set this up, we know that 1 foot we know that 1 foot is equal to a resistance of 1.65 ohms. So what length do I need if I want to have a resistance of 19.8 ohms? So in a directly proportional relationship, if you were to set up your proportion, you can start like here with my 1, I started in the upper left hand, so the numerator on the left hand ratio. That number corresponds with, so that length corresponds with the resistance that I also put in the numerator of the second part of my ratio, and then so on and so forth. So to go ahead and solve this, we multiply like we've been doing. Remember that cross products are the same. So 1 times 19.8 is 19.8, and 1.65 times L is going to equal 1.65 L. Since I want to solve for L for that length of my longer wire, I'm going to divide by 1.65 on both sides of my equation. And you're going to get 12 feet for this one. So L should be 12 feet. Okay, for the next one, we're going to talk about paint and how many square feet it covers. So on this one, we're still doing a directly proportional relationship. So it says 1 gallon of paint covers 825 square feet. How much paint is needed to cover 2,640 square feet? So I can start by setting up my proportion. I'm just going to draw 2 fraction bars with an equal sign. I'm going to go ahead and put my 1 gallon up in the numerator of my first ratio. That corresponds with 825 square feet of coverage. So then how many gallons do I need to cover 2,640 square feet? So notice that I'm putting gallons of paint as one ratio and I'm putting square footage as the other. Now as I start solving, remember once again, cross products are equal. So 1 times 2,640 is 2,640. X times 825 is 825x. Now we want to get x by itself, so we divide by that coefficient of 825. And that's going to give us about 3.2, and we were talking gallons of paint, so 3.2 gallons for x. Okay. Another one is going to talk about a vehicle that's driving a certain amount of miles on a certain amount of fuel. So once again, we can set up our proportion as a fraction equals another fraction. That's how you do proportion. Ratios are equal. Now, a diesel truck was driven 273 miles on 42 gallons of fuel. So I'm going to drive 273 miles, and that's on 42 gallons of fuel. How much fuel, so there's my x, how much fuel is needed for a trip that is 600 miles? Now once again, cross products are equal, so 273 times x is 273x. And 600 times 42 is going to be 25,200. Okay, in solving for x, I'm going to divide by 273. And for this one, x is about 92.3 because it says, well, it's about 92.3, but it does say that we need to round to the nearest gallon. So we're going to do 92 because we're going to round down 92 gallons. Okay. On the next side of your notes, we've got one more here of direct proportions. So a cylindrical oil tank holds 450 gallons when it is filled to its full height of 8 feet. When it contains oil to a height of 2 feet 4 inches, how many gallons of oil are in the tank? So when setting up my proportion, we've got to make sure that we also have the same units when we're comparing these. So a cylindrical oil tank holds 450 gallons, and that's when it's filled to the top at 8 feet. Now, when it contains oil to a height of 2 feet 4 inches, how many gallons of oil do we need, or will it hold? So we put X in for the gallons of oil. But for this one, this right here is 2 feet and then 4 inches out of 12 feet. So that's going to be 2 1/3. Now you can do a repeating decimal here, but I recommend going ahead and using your fraction on this one. So I've got 2 1/3, and that was in feet. So what we did is we converted that to feet and got rid of the inches part. Okay, so with that, let me erase the label up here. Cross products are still equal, so we do 450 times 2 1/3, so 450 times 2 1/3 is going to give you 1,050. And x times 8 is 8x. So when I divide by 8, we're going to get 131.25, and this was asking how many gallons of oil are in the tank, so this would be gallons. Now, an inverse proportion, where a direct proportion increases as one value increases, the next increases proportionally, or as one decreases, the second also decreases. Inverse is opposite. So as one quantity increases, the other quantity decreases proportionally. So as one goes up, the other goes down. These are said to be inversely proportional. Okay, so you have in your blue box shows that as the first value increases, the second decreases, or if the first value decreases, then the second increases. So for this first one, it says, if a certain trip takes 2 hours at 50 miles per hour, how long will it take at 60? We know this is an inverse proportion because if you increase the speed that you're going, it's going to take less time to get somewhere. So if I know that I need to be somewhere and I'm running late, what do we tend to do? Well, we tend to speed up a little bit because we know that's going to cut our trip down. So I'm increasing my speed but decreasing the time it takes to get to wherever I'm going or to cover my mileage. So that's where this is an inverse proportion. So when you set this one up, inverse, remember, I said meant opposite, or in this case, it's going to mean flipped. So when I start, I know that my trip takes 2 hours at 50 miles per hour. This time, you're moving your 50, so instead of going straight across my equal sign or my equation, I'm going diagonal. So when I multiply, I should be taking 2 hours times 50 for my cross product. So then it says, how long will it take? So that's our x, that's our hours, at 60 miles per hour. So the first trip at 2 hours over the second trip at X hours is equal to the second trip's speed divided by the first trip's speed. So we flipped that second fraction. It's an inverse. So now when we multiply, we have 2 times 50, which is 100, x times 60, which is 60x. Then we're going to go ahead and divide. So when I divide by 60, I'm going to get a repeating decimal in my calculator. So I'm going to get 1 2/3, or about 1.67. And this is in hours. And I rounded because it's 1.6 repeating. That means that this is actually 1 hour, and then 2/3 of an hour would be 40 minutes. So once again, this as a fraction is 1 2/3. Okay, next. In an automobile cylinder, the pressure is inversely proportional to the volume if the temperature does not change. So it says if the volume of gas in a cylinder is 300 cubic centimeters when the pressure is 20 psi, what is the volume when the pressure is increased to 80? So on this one, if you take a certain amount of gas, in this case in a cylinder, and you take that volume, or I should say you take that, you take that volume and you decrease the volume. You're not decreasing how much gas is in there. You're just decreasing the space that it's allowed to take up. So it's going to build pressure. Think about like a stress ball, or if you've ever made the stress balls in like your health class, made out of the balloons, and then they have like the flour or baking soda in them. So, or sand. So the more you squeeze a part of that stress ball, the more pressure there is. You've got the same amount of volume in it, but you're compressing it, and so you've got less space that's allowed to take up. So then like the balloon itself, or whatever your stress ball is, or like there's Neato balls and color changing fidgets and that out there. As you squeeze them, that surface tension is a lot higher than what it was if you didn't squeeze the ball. So that's what's happening here, okay? So as my volume decreases, my pressure increases. So that's why it's inversely proportional. So looking at this first problem on B, we have a volume of 300 cubic centimeters, and that's when the pressure is 20 psi. I want to know what is the volume in cubic centimeters when the pressure is increased to 80. So those are across from each other. So 30 times 20 is 6,000. 80 times x is 80x. Then we're going to go ahead and divide by 80 to get x by itself. And when we divide that, we're going to get 75 cubic centimeters. So this is 75 and then cubic centimeters. So CUCM. So 75 cubic centimeters of volume is what we have to decrease our volume to in the cylinder if we want to increase the PSI to 80. Okay, let's look at the next one. So for the next one, we've got another pressure one. On this one, it says for gases, pressure is inversely proportional to volume, once again, if the temperature doesn't change. So this time we've got 30 cubic feet of air at 15 psi is now going to be compressed down into only 6 cubic feet. So we know the psi, the pressure is going to go up. So what is the new pressure? So as I set this up, we start with 30 cubic feet, and that is 15 psi. Then we are compressing that to only 6 cubic feet. So what is the new pressure? So I'm going to go ahead and find my cross products. 30 times 15 is 450. 6 times x is 6x. Then I'm going to divide by 6 on both sides of my equation. And I'm going to get 75, and this was, what is the new pressure? So it's PSI. So 75 PSI is equal to X. Okay. When you look at gears, okay, for the gear assembly shown, if gear A turns at 40 RPMs, that's revolutions per minute, what is the speed of gear B? So gears, and like on the next one with pulleys, these are inversely proportional. The more teeth you have on a gear, the slower it's going to go. So as you increase the teeth, the speed of the gear slows down. And part of that's because, as you can see in our picture here, the gear has to be bigger in order to have more teeth and then still be able to fit up with smaller gears. So you have the speed of gear A over the speed of gear B is equal to the number of teeth in gear B over the teeth in gear A. So for the gear assembly shown, gear A is turning at 40 RPM. So gear A has a speed of 40 RPMs, and that's for 16 teeth. Now, we want to know the speed of gear B, so we don't know that. I'm going to put an X. You can put a B if you want for gear B. But we know it has 80 teeth. So now we multiply. Cross products are the same. So we have 40 times 16, which is 640. Then we have X times 8, which is 8X. And when I go to solve for X, I divide by my 8. And I'm going to get 80. And this was the speed of gear B. So this would be RPM. So 80 RPMs is X. So if gear B has half the amount of teeth of gear A, then it should move twice as fast. Okay. And on our next one, we have a pulley problem. So we take the speed of pulley A over the speed of pulley B, and that's equal to the diameter of pulley B over the diameter of pulley A. So we've got a picture here of your pulleys, like with a belt. And it says if pulley B is 16 inches in diameter and is rotating at 240 RPMs, what is the speed of pulley A if its diameter is 20 inches? So here we're looking for the speed of pulley A. We don't know what that is. I'm going to use an X. Once again, you can use an A or whatever you want there. Now the speed of pulley B was rotating at 240 RPMs, and that's because it is a 16-inch pulley. Now pulley A has a diameter of 20 inches. So we need to figure out what that speed is. Okay, so cross products are equal. We have 20x equals 240 times 16, which is 3,840. We divide by 20. That's about 192 RPMs because we were once again looking for speed. So it's in RPMs. Okay, and last but not least, we got one more pulley problem. So this one, and you can feel free to pause the video anytime and try this one on your own. We have a 9-inch pulley on a drill press that rotates at 960 RPMs. It's belted to a 5-inch pulley on an electric motor. We need to find the speed of the motor shaft. So I'm going to set up my proportion. We have a 9-inch pulley. I don't need to put my label. We have a 9-inch pulley on a drill press that is rotating at 960 RPMs. So those are set up diagonal of each other. Now it's belted to a 5-inch pulley on an electric motor. We don't know how fast that motor's going. So we're going to put an X there. Okay, so just like before, cross products are equal. 9 times 960 is going to be 8,640. 5 times X is 5X. When I divide by 5, I should get 1,728, and this is RPMs. Because once again, we're looking at speed. So the speed of the electric motor is 1,728 revolutions per minute. Okay, with that, you can go ahead and start on your assignment.